All right, now let's solve question number 2. And question number 2 is a question from momentum. Let's see what it says. Figure 2 shows a particle, shows two particles, in fact, A and B, moving in opposite directions on a smooth horizontal surface. Particle A has mass 5 kg and particle B has mass x kg. The particles collide directly. Immediately before the collision, the speed of A is 3 meter per second and the speed of B is x meters per second. All right. Immediately after the collision, the speed of A is 1 meter per second and its direction of motion is unchanged. So that means A, which is moving towards the right, after collision will continue to move towards the right. Now, an interesting uh, thing to think about would be that what about the direction of B? Well, if you think about it, since A continues to move towards the right, that means B will also move towards the right as well. Okay, it's not possible that A moves towards the right and B also continues to move to B also continues in the same direction, because obviously B cannot go through A, nor can it go above A or under A. Okay, so if one object is moving towards the right after hitting another object, that means the other object must also be moving towards the right. Okay, you won't find this mentioned in the question because you really have to use your common sense here to figure this out. Anyway, so immediately after the collision, the speed of B is 1.5 meter per second. Now, if you've seen my videos, you know that I like to solve these questions in a systematic manner. And that is, the first thing that we do is we say that the rightwards direction we're taking as positive. So every velocity towards the right will be taken as positive. So I like to make these before columns and then the after columns. Okay, so let's talk about the mass and the velocity. So mass of A is 5, mass of B is, what's the mass of B? We're not given, that's x. Okay, now as far as the velocity is concerned, that's 3. As far as the velocity of B is concerned, so interestingly, B has mass x kg, and also the speed at which it's moving is also x meters per second. Okay, but do keep in mind that it's in the opposite direction as A, which is considered as positive, so that means it's going to be taken as negative. Now, when we talk about the after situation, so the mass will obviously remain unchanged. The speed of A right after the collision and the direction remains, the speed changes obviously, but the direction remains unchanged, so it's positive 1. However, the speed of B, since it's moving towards the right now, will be, the velocity will be positive 1.5. Okay, now let's solve this. Momentum before collision we know is equal to momentum after collision. Okay, let's write that down. Momentum, or you can say the law of conservation of momentum. So momentum before equals momentum after. All right, so momentum before would be 15 minus x squared is equals to momentum after, which is 15 plus 1.5x. Okay, now let's move all the terms to the right hand side. So we have x squared plus 1.5x, 5 minus 15, what's that equal to? That's equal to 10, equals to 0. Now, we can multiply the entire thing by 10 to get rid of the decimal, or we can also multiply it by 2, because 1.5 times 3 is equal to 1.5 times 2 is equals to 3. Okay, and our objective is to somehow just get rid of the decimal, so we can solve it. So once I multiply both sides by 2, we have 2x squared plus 3x minus 20, and the objective behind doing this is so that I can solve it easily with the help of middle term breaking. So factors of 40 that leave us with positive 3, that's going to be 8 and 5. So 2x squared plus 8x minus 5x minus 20 equals to 0. So we have 2x into x plus 4, then we have minus 5 into x plus 4 equals to 0. So 2x minus 5 times x plus 4 equals to 0. So x is equals to 5 upon 2, or you can say 2.5, or x is equals to negative 4. Now bear in mind that x is not only the velocity, it's not only representing the velocity, it's also representing the mass. So while the velocity may be negative, but although that's not going to be the case, but in this case, since x is also representing mass, that means we cannot take the negative value. The only value that we're going to take is 5 upon 2, or 2.5. So that's the value of x, which is the correct value, the acceptable value, and that is the end of part A. Now let's have a look at part B. Part B says, find the magnitude of impulse exerted on A by B in the collision. Okay, so we're talking about A. So we're going to find out what are the changes that have taken place on the velocity of A. Okay, so remember, what's impulse equal to? Impulse is basically the change of momentum. Okay, so impulse is basically the change in momentum. Now, change in momentum will occur if there is a change in velocity. So, mass into final velocity minus initial velocity. And also do bear in mind that the question is only asking us for the magnitude. So, and we're talking about A here. So, what's the mass of A? 5. What was the velocity of A after collision? It was 1. And what was the velocity right before collision? It was 3. So that means final velocity is 1, initial velocity was 3. So 5 into -2, that's equal to -10 Newton second. And remember, this is the impulse, but since the question is asking us for the magnitude of the impulse, that would simply be equal to 10 Newton seconds, and that is the answer to part B. So fairly easy question. In fact, I think the entire paper has been fairly easy so far, which is good news and bad news, because if it has been easy, well, we can only sort of imagine what comes next. But at least so far, we have done everything correctly. So let's see what question number 3 says.